All right, the lesson's on trig identities. There are three basic trig identities that you need to know. And there's more, like a lot more. But these are the basic ones that we're going to work with for this lesson. The quotient identities. Quotient means dividing. Tangent is equal to sine over cosine, and the reciprocal, cotangent is equal to cosine over sine. Reciprocal identities, which you know, cosine is the reciprocal of secant and vice versa. Sine is the reciprocal of cosecant and vice versa. And tangent is the reciprocal of cotangent and vice versa. Now these three are a little bit new. The Pythagorean identities, really important to know. Sine squared plus cosine squared equals 1. This makes sense when you think of the unit circle as a right triangle, and you know that that point, x and y, to describe that right triangle, you go x squared plus y squared equals 1 squared, because that's the radius of the unit circle. And that x goes with cosine, y goes with sine. So this makes sense. These are all rearrangements of this same identity. So the primary one, sine squared plus cosine squared equals 1. Super important. Tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. These are actually will be important in calculus because sometimes we have to do substitutions to integrate, whatever. But they're also going to be important. It's also important to realize that you can rearrange these. So if I want to take cosecant squared, I can then subtract and realize cosine squared is equal to 1 take away sine squared theta, and then I can use it that way. Same thing here. I can rearrange these and then plug in as necessary. The whole goal today is to be able to simplify trig expressions to make something that's a little complicated or a lot complicated and to make it simpler. So in example number 1, usually the first rule really is change everything to sine and cosine and work with it. Sometimes that doesn't work, but most of the time, if you change it to sine and cosine and then simplify, it then works. So cotangent, I have two options here: 1 over tangent, or cosine over sine. I'm going to change it to cosine over sine, because my first direction is to change everything to sine and cosine and simplify it from there. Cosecant is 1 over sine, the reciprocal of sine. And then to divide fractions, I multiply times the reciprocal. Sine thetas divide out, and then what I'm left with is cosine theta. So this and this are equal to the same, and you simplify a trig expression. Example number 2. So I'm going to change cosecant to 1 over sine. I'm going to change tangent to sine over cosine. So this is called the reciprocal identity. This is the quotient identity. Notice sine thetas divide out. I'm left with 1 over cosine theta. What's the reciprocal of cosine? And I have my answer. We try to simplify it so there's no fractions, and we're just left with one trig identity at the end. That's the goal, to make it simpler. In example number 3, this is a little bit more the next level up. Can you simplify this expression? And often in this situation when you have fractions, we need to make common denominators. So in order to make common denominators here, I'm first going to multiply top and bottom by cosine theta, and then I'm going to multiply top and bottom by sine theta so that I can get common denominators. So I have 1 plus sine theta times cosine theta. I have cotangent theta, subtract cosine theta times sine theta. And now we have one denominator, which is sine cosine. So there's a good first step. Do you have the algebra ability to write it as one fraction? Now we're going to work here. We're going to distribute. So cosine times 1 is cosine. Sometimes it doesn't feel like it's getting simpler until we get near the end of the problem and see things that divide out. And then we have sine cosine. In order doesn't matter. It could be cosine sine. Over here, we have sine times cotangent. And we have subtract. And sine times cosine. I'm just going to write it like that so you can see what the next step is going to be. Now, sine cosine, subtract sine cosine. They eliminate. I have cosine theta Now, I want you to notice cotangent. I'm going to now write that differently. So one of the definitions of cotangent is cosine over sine. So I'm going to write that down. Again, I'm trying to write everything in terms of sine and cosine as a step, and most of the time that works. If it doesn't work, we'll have to go in a different direction. Notice how when I do that, the sine thetas divide out. Now what am I left with is cosine theta plus cosine theta. Well, that's 2 cosine thetas. Now do you notice how it's getting simpler? So the cosine thetas are going to divide out. 2 over sine theta. Well, what's the reciprocal of sine theta? Oh, I was almost going to do that here, right? What goes to sine theta? It's cosecant. And you have your answer. So our answer at the end, we don't want a fraction, and we don't want multiple trig ratios if we can help it. If we can simplify all this, no fraction, 1 trig ratio, then we fully simplified it. All right, example number 4. Here's an example that changing it to sine and cosine may not be helpful, because ultimately our goal is to try to write it all with the same ratio and then simplify it. So instead of sine over cosine, I'm going to write it this way. I'm going to change cotangent to 1 over tangent. And that's also helpful if you only have one ratio to work with. I'm going to get common denominators in the denominator. So instead of 1, I'm going to write it as tangent theta over tangent theta, so that I have common denominators. And then I'm going to write it as 1 fraction. So I have that common denominator of tangent theta. Tangent theta plus 1, they just go beside each other. Next, I'll do that here. We're going to multiply times the reciprocal. So the reciprocal of this is tangent theta over tangent theta plus 1. I'll put parentheses around here so you can see it. So what would our next step be here? Notice these divide out. You can add in any order. And then what are we left with is the answer tangent theta. Believe it or not, some really enjoy simplifying trig to see the puzzle involved, to be able to simplify it algebraically. And I know others, this is a challenge. But I don't want you to back away from the challenge. So example number 5. So they're already in sine and cosine, so to like that, we have 2 fractions. So my first step is going to write it as 1 fraction. So to do that, I'm going to take the other denominator and multiply top and bottom by it. So sine times sine is sine squared. To the other side, 1 plus cosine theta. I'm going to multiply this side by 1 plus cosine theta, top and bottom. And then multiply these together. So now we have 1 fraction. So I have sine squared here. I have 1. Now I'm looking at the right side. So 1 plus cosine theta times 1 plus cosine theta. I'm going to have to FOIL, but with trigonometry, which sounds a little challenging, but it's not bad. We're going to do it together. So 1 plus cosine theta times 1 plus cosine theta. Distribute, FOIL. 1 times 1. 1 times cosine theta. And then cosine theta times cosine theta is cosine squared theta. Remember that when we have an exponent for trigonometry, we write it in the middle between the name and theta. I'm going to go back here. So I have sine squared theta, and now this replaces this. So I have 1, I have 2 cosine thetas, and I have a cosine squared theta. And now I need to keep simplifying. What do I see that could help me simplify it? So often when I see squared terms, that obviously reminds me of the Pythagorean theorem and the Pythagorean identities. So sine squared plus cosine squared, sine squared plus cosine squared just equals 1. So then I can replace these with a 1 to simplify it. Now 1 plus 1, I got that. All right, so here we are now. We've combined like terms. Here we are. Next, I'm going to factor. What do they obviously have in common is a 2. So I'm going to factor out a 2. And hopefully, when you do this, you start to feel like you're playing maybe chess, where you see a couple steps ahead. So as you're simplifying, you're recognizing what's happening to simplify it as you go forward. That's how you know you're getting stronger with this, is that you see the work you're doing a couple steps ahead would be able to lead to a good result. So I see 1 plus cosine theta divides out. I'm left with 2 over sine theta. So I don't want a fraction. So what's the reciprocal of sine? And you have your answer. All right, one more example for the lesson. Tangent theta plus cotangent theta equals secant times cosecant. So it's already one fraction. We have multiple trig ratios here. So I'm going to write everything with sine and cosine to simplify it. So tangent is sine over cosine. Cotangent's the reciprocal. That's cosine over sine. Secant is 1 over cosine. And cosecant is 1 over sine. Sometimes I have brain lapses too. Human. All right. In the numerator, I want to write this as one fraction. And then I'm going to go sine. So multiply top and bottom by sine. Multiply top and bottom by cosine. And I wonder if you already see the kind of direction we're going to go when I look at this. So do you notice sine squared plus cosine squared? Now you're thinking. Do you see cosine theta times sine theta? And notice we have common denominators. These divide out, and then sine squared plus cosine squared is equal to. So this whole thing is just equal to 1. All right, Mr. G Math, over and out. Till next time.